The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, thanks so much for joining us. We're going to give everyone one more minute to join, and then we will go ahead and get started. Okay, let's go ahead and get started. Good afternoon, everyone. Thank you for joining us for today's webinar titled A First Step Towards Test Automation. My name is Lauren Izoni, and I help coordinate the trainings here at CC Pace. Just a little bit about us. We are a 37-year-old IT consulting company, and we have three main areas of business: staffing, financial services, and Agile services. Under our Agile services umbrella, we have custom development and training and coaching. With training, we offer both public and private training, and of course, webinars. If you have any questions throughout the webinar, we encourage you to submit them in the question box. It's located on the right-hand side of your screen. And then at the conclusion of the webinar, we will do our best to answer as many as possible. So just submit them as they come to you throughout the webinar. And with that, I will go ahead and turn it over to today's instructors, Bobby and Ashok.
Thanks, Lauren. Hello, I'm Ashok Kumaragiri. I am a lead technical consultant with CC Pace, and I come from a Java development background. I have about 10 years of experience in software and web application development using Agile practices like Scrum and XP. My experience with test automation comes from the fact that I've practiced test-driven development and behavioral-driven development on most projects that I've been a part of. And so I consider myself quite familiar with these Agile engineering practices and concepts. I've been a technical consultant on a lot of different projects, a lot of different clients, from nonprofit to commercial to federal. On my more recent engagements, though, I'm helping companies in their digital transformation by guiding them with Agile engineering and DevOps best practices. And I am a certified Scrum Master as well.
Great. All right, I'm Bobby Pantel, and I have over 15 years of Agile development experience. After learning about extreme programming, XP, and test-driven development, or commonly known as TDD, I've been interested in automating most aspects of the software delivery process, including UI testing. I believe this leads to more predictable and maintainable applications. Now, most of my experience has been in Microsoft technologies and frameworks, especially the .NET framework, C#, ASP.NET MVC, and some F#, as you'll see. So what does this webinar cover? We'll start off by discussing the different kind of tests that you would need on an Agile project. We'll talk about which of these should be automated, and then discuss where manual testing fits in with Agile. Then we'll talk about some important considerations and best practices, especially when moving away from manual testing and taking that first step towards automation. Then we'll talk about functional automated tests. And then we'll end with a demo showing you some examples of functional automated tests on a real application. We'll use two different frameworks, one in the Java space and one in the other in the .NET. So Ashok, why don't you give us an intro to the Test Quadrant?
Sure, Bobby. The Agile Test Quadrant really is one way to model the various types of tests that one would need on an Agile project to ensure the delivery of a high-quality application. So if you're transitioning from a more traditional waterfall approach to Agile, or even taking those first steps towards test automation, the quadrant helps to understand the different types of tests that you need to perform, where they fit in, and it also helps define the purpose of each of those tests. The test quadrant basically categorizes tests based on whether they are business-facing or technology-facing, and whether they support the development effort or are used to critique the project. The first quadrant, the one that is technology-facing and supports programming, contains tests that are by the developers and for the developers. Now, these tests typically include unit tests, component and system tests, etc. The tests in this quadrant are written by the developers and are mostly for them to validate their work. The tests in this quadrant are almost always automated using either JUnit, TestNG, NUnit, or similar frameworks. Now, at the very minimum, your continuous integration workflow must definitely include the test from within this quadrant to run upon every check-in. The second quadrant, the one that is business-facing and supports the programming effort, consists of functional acceptance tests. The tests in this quadrant mainly help in answering the following two questions. How do I know when I'm done for the developers? And did I get what I wanted for the product owners? The tests in this quadrant could be a combination of both automated as well as manual tests, and is usually a collaborative effort between the different members of the team, both in coming up with these test cases as well as in implementing them. The third quadrant, the one that is business-facing and critiquing the project, are the ones that the testers on a Scrum team could mostly focus on, given a comprehensive set of tests from the first two quadrants. And this is where manual testing fits in within Agile. Now, the tests in this quadrant typically include showcases, usability, and exploratory tests, and the tests in this quadrant are almost always manual in nature. So, for example, it does not make sense to automate a usability test. That's something that has to be tested manually. The last quadrant, the one that is technology-facing but critiquing the project, are the ones that focus on the non-functional aspects of the system, like security, compliance, performance, etc. The tests in this quadrant, like its functional counterpart, can also contain a combination of both manual as well as automated tests. So as you look at this test quadrant, the tests on the left really help ensure that the developers are building the right code, whereas the tests on the right help ensure that the code is working as expected. Now, it is important to understand that the idea here is to not work through those tests or the quadrants in that particular order. Right? That defeats the whole purpose of Agile. But instead, you should use this quadrant to think of all the tests that you would really need on an Agile project to successfully build and deliver a quality product. For the purposes of this webinar, though, we're going to scope our discussion to just the functional acceptance tests, the one that fall in the second quadrant, which is business-facing and supporting the programming effort. Now, what's acceptance tests, right? Now, the acceptance testing, by definition, is to ensure that the acceptance criteria of a feature or a story is met. And when such tests focus on the functionality of the system under test, they become functional acceptance tests. Typically, when you think of a feature to implement, it can be broken down into a set of rules and examples. Rules form the acceptance criteria of the feature, and the examples are based on that acceptance criteria. A feature can also be broken down to one or more user stories, and you could have the acceptance criteria at the user story level as well, but the concept still remains the same. A major aspect of functional acceptance testing is in coming up with these rules and examples for the features that are going to be worked upon within a given sprint. But once you've done that, if you have a high-performing team that is very experienced with functional acceptance testing, the developers might account for most of these examples while building the functionality itself, and that offloads a lot of time and effort from the testers within those Scrum teams, and they can now focus more on the showcase, usability, and exploratory testing that we talked about in the test quadrant. But for a team that is relatively new to functional acceptance testing, implementing these examples is still going to be a shared responsibility between the developers and the testers within that Scrum team. The developers might account for a subset of these features while building the functionality itself, the happy paths, for example, and the testers within the Scrum team might account for the remaining cases. So who comes up with these rules and examples? At the very beginning of each sprint, the developers, testers, and the product owners, the three amigos, should all come together in defining these rules and examples for every single feature that will be worked upon within that given sprint. Now, this approach helps the whole team to clearly understand what the acceptance criteria is for those features before the developers start building the functionality itself. And this involvement and collaboration between them really benefits the whole team in that the product owners start to get more familiar with some of the testing concepts. The testers understand some of the development concepts and practices. We're working closely with the developers. And the developers learn more about testing as well by working closely with the testers. So it's really a win-win for the entire team. These examples typically are end-to-end tests and are based on the behavior of the system, how the system would behave for that specific feature. Furthermore, if you're adopting a BDD tool like Cucumber, JBehave, or SpecFlow, these examples can also be written as executable specifications in a gherkin format. So here are examples of test cases written in gherkin format. Now, I'm not going to go over these test cases now. We'll talk about it more during the demo, but a gherkin test case is typically in a given, when, then format. Notice how readable the tests are. The English-like language and structure of gherkin also helps the non-technical people on the team in coming up with these test cases as well. So the standard structure of a gherkin test is given some initial context when an event occurs, then you assert on a certain outcome. Now, when you're thinking about test automation and working towards building your suite of automated tests that include unit, component, system, and acceptance tests, whether functional or non-functional, it also helps to think in terms of the automation test pyramid. what we are essentially saying with the help of the test pyramid is that while testing the system at these different levels, try and build as many automated tests as you can at the levels that form the base of the pyramid than at the tip of the pyramid. So as you can see, your unit tests should really make up the most percentage of your automated tests, followed by integration, component, system, and acceptance tests that are not testing the system through the UI. Acceptance tests, testing the system through the UI, forms the tip of this pyramid and should really make up the least percentage of your automated test suite. Now, this is because UI tests are typically flaky in nature, and any slight changes to the UI tend to break these tests, resulting in a lot of false positives. Furthermore, UI tests take longer to execute as compared to tests in the lower layers of the pyramid, and the cost to fix these tests increases as we move towards the top of the pyramid as well. So it really is important that you plan your test automation suite based on some of these concepts that we just discussed.
Okay. So now we'll get into the demo. We laid out the different kinds of tests using the test quadrant. We talked about functional acceptance tests in detail, covered some automation best practices as well. So let's take a look at some examples of functional acceptance testing. So we're going to show you some examples from a real application that we helped develop, and we're going to show them using two different frameworks: Serenity, which is a Java-based framework, and Canopy, which is based in .NET. We'll go through the demos first and then compare the tools at the end. So first, a little bit about our test subject today. It's a website for an organization called the Sika Foundation. So this is a charitable foundation with whom we've worked the past few years. They've got a great mission to celebrate caregivers through peer recognition. Participants in this program include hospitals, rehab centers, assisted living, and nursing homes. Caregivers log into the website, submit a nomination for their peers, and then they can view, comment, or love other nominations. At the end of an award period, a selection panel chooses a nominee to receive a monetary award. So today we're going to automatically submit a nomination. The steps are: log into the Sika nomination website, view a list of nominations, search for the nominee and choose them from a list, select nomination criteria, and submit. We're also going to have another example of opening my profile, opening your own profile, and then changing and saving an attribute. So let me walk through a quick example here. This is the site. I'm going to log in. This is just manual to start out. And then I'll show you how we nominate automatically. We'll give that a second. So as you can see, there's a list of nominations here. My profile's to the left, and then I nominate by going up here, do a quick search, and then choose some attributes. So the idea here is that we want, this is in a smoke test environment, instead of having someone manually go through and submit a nomination, we want to automate this process. So these tools make it a lot easier. So I'm going to go ahead and close this out. So that's an example of a nomination, and I'll walk you through an example using Canopy. So I want you to focus on this part here. This is the actual meat of the test. Some of this is just dependencies, setting up dependencies, constants, and starting the Chrome driver. But inside the test, I feel it's very expressive and clear what's going on. So a describe just happens to print something out to the window, as you'll see when we run it. But other commands like URL, click, should be very clear what they're going to be doing in a UI environment, in a website environment. There are input fields that accept values, and in this case, we have a configuration that pulls user IDs, passwords, or something that may change depending on the environment. So one other thing to focus on here is that things like login button, search box input, these are part of a constant file. I'll show you that. And what that does is it hides the complexity of some of these CSS selectors. Now, a big part of UI testing is finding out what those HTML elements are using things like XPath or just finding the exact using an ID or something indicating what that element is. And that can be a little bit messy. So we want to hide some of that complexity. And this is where someone that has experience choosing those selectors can put them in a constant file, and then the person writing the test can just use those in their natural, in a more readable variable format. So a couple things you'll notice, we have a couple sleeps in there just to allow the process to finish, such as searching or nominate or submitting the nomination. And then we have another test here, which it says sending a test nomination, but this is actually editing the profile. So let me just make sure I change that. And we'll go ahead and run it. And you can see on the left, you'll see the output from the command, and it's actually generated a window automatically. So you can see it walk through. Now, ideally, these functional acceptance tests will be written while coding the features. As Ashok mentioned, the three amigos would work together to come up with end-to-end tests for core functionality. Then you can use them to smoke test the website after every release. So as you build your application, you also want to build a suite of regression tests. We use them, we build a suite of regression tests using unit tests, but this is also useful on the UI. Let that process. And then it's quickly going into the profile, which is very quick, but you'll notice that the about me changed, and we put a timestamp there. So I'll close that out. So that's just a quick example of the Canopy tool using the Visual Studio environment and the F# language. Now I'll turn it over to Ashok to show you another example.
Thanks, Bobby. So I want to show you all the same set of examples using Serenity, right? Serenity is not a tool that you install, but rather these are libraries, or the framework is a bunch of libraries that you add to your project as dependencies, right? So I'm using Maven here on my project for dependency management and as my build tool. So I have my pom.xml that lists out all the libraries that I need as dependencies. And here's a typical project structure as well. This is created using a Maven web app template. I have all the application source files that go under the source main directory. I have all the test sources go under the source test directory. Then I have the source test resources directory here, and that contains my feature files, right? The feature file is really what contains the gherkin test. Now, I have two feature files here, one for the nomination, and the other is the edit profile workflows that Bobby went over. So let's open one of the feature files, the nomination one, and see how readable, again, this test is, right? So given I log in as a registered user, when I search and nominate Bobby Gmail, then I should see the nomination at the top of the list. Simple test, right? Now, notice how I also kept it at a very high level, right? It doesn't go into breaking it down to given I enter a username and I enter a password and I click on a login button, for example. You want to avoid that, you want to keep it at a high level. Again, the concept here is thinking in terms of how the system should behave for that specific feature or functionality. Right. So every feature file has a corresponding step definition file. And they're all under the test resources directory here. So I'm going to open the step definition file for the nomination feature. And here's what it looks like. As you can see, each line in the feature file maps to a corresponding method in the step definition. Now, the step definition file uses a bunch of steps, right? Steps is a concept in Serenity, which is nothing but a plain old Java object, but it's a logical grouping of related actions. So here's an example of the login steps. Right? I just have one method in this class, and that's to log into the application, but I could have other methods that are related to the login functionality. For example, reset password or forget password, etc. Right. Now, Serenity also supports the page object model design pattern. The page object model design pattern really says that for every page of your application, have a corresponding Java class with all the elements listed as members of that Java class, and define methods that perform the action on those elements. So here's an example of a login page. Right? You have the username text box, you have the password text box, the login button. These are all the different elements on the page. And then you have these methods defined that are performing certain actions on those elements, like entering a username, entering a password, and submit credentials, etc. Right. Again, this is just a plain old Java object that's managed by Serenity. Right. And you notice the default URL here. Now that's used by Serenity to pop up a browser and browse to that URL. It's all managed by Serenity. Now, to really run these tests, you would define what are called as step runners. Now, here are the step runners that I have, and you could have one step runner that runs all the test cases given the feature files, or you could have a test runner corresponding to each feature file. So I have this nomination test runner, for example, for the nomination feature, and I have the profile step runner for the other feature file that I have. And there are also multiple ways to run these step runners as well. Right? One way is to run it through Maven, and the other way is to just run it through the IDE. So you run it through the IDE by just right-clicking on it, clicking on the Run button here, and that should pop up a browser instance. So let's just do that. So here, I've started the test runner. Again, this test runner should run through both those workflows. So it's opened up a browser instance, and it's going through all those steps that are in those feature files. Right? So the first step is really enter the username, password. You get to this login page. You're searching for a caregiver. And there are implicit weights that I've put in, and that's also a nice little feature of Serenity. It kind of encapsulates the WebDriver, the Selenium WebDriver API, so you don't see those manual weights that you would typically have to introduce with Selenium. So here I've selected the caregiver, and I've nominated it, and see how it's closed the browser instance and opened up a new one for the other workflow. So again, you log into the application, you get to the landing page, you go to the edit profile page, you've made the edits, and it's closed the browser instance. And here's an indication of the test passing. All right. Now, when you run these tests through Maven, it also spits out a nice little report capturing all the screenshots while it's running through those test cases. And you could have that published to your CI server, for example. Right? So that's another alternative way of running these test cases through Maven or Gradle or any other build tool of your choice. So now we've looked at the examples. Now let's discuss how the tools differ, under which circumstance you might use one over the other. So the biggest advantage of Serenity is that it does not limit testing to any one particular layer of the automation test pyramid. It can work well with all three layers of the pyramid. The underlying programming language is Java, which again is very popular among the software development community. So it's easy to find resources who can work with this framework. Now you need some programming discipline though to work with Serenity, or else it can be difficult to maintain those tests as you build the test suite. Now another advantage is that Serenity out of the box comes bundled with Cucumber that supports behavioral-driven development and gherkin tests. And it also comes bundled with Rest Assured for API testing, for example. And also because the underlying language is Java, it enjoys a great community support as well. Now, Serenity also offers a great abstraction layer with its own API rather than the test having to directly interact with the Selenium WebDriver. And this direct interaction with the WebDriver is usually what makes the UI test more flaky and more brittle. So using the Serenity framework or the API to write these UI tests makes them more stable.
Okay. So on the Canopy side, so a little bit in contrast here, Canopy is more suitable for UI testing, which is at that top of that test pyramid that Ashok went through. Now, because it uses the .NET framework, you can write tests for the more foundational parts of the application like API and unit tests, but the Canopy tool was built for ease of use for functional acceptance testing. So you can do more with it, but it really, the Canopy tool on top of the framework really is supposed to make it easier for UI tests. Now there's a slight learning curve with F#, as it's not a common language, but again, because it's the .NET framework, you can import dependencies written in, say, C# or some other language that can be compiled to the .NET runtime. So there's a pretty low barrier to entry for Canopy. On our projects, traditional QA testers have completely taken over the maintenance and development of the Canopy UI tests. So there's no out-of-the-box support, as talking about the gherkin and BDD concepts. There's really no out-of-the-box support for the gherkin BDD format. But as hopefully you saw, the natural format of the tool is very readable. As far as community support, compared with Serenity, there's not a big community, but there's plenty of support for getting started with basic UI testing. There's also many extensions available on the web to help with common tasks. And lastly, Canopy is very forgiving. If it can't find an element, a UI element immediately due to, say, the slowness on the site, it will retry automatically. And most of the time, you can simply use a button's text value as its identifier rather than trying to figure out the exact CSS selector. So it makes it a little more easier to use the identifiers rather than looking at complex CSS selectors. So what's the verdict? Our thought is just pick a tool that seems the most comfortable in terms of functionality and maintainability, and try it out and adjust based on feedback. Don't spend a lot of time analyzing which is the perfect tool, or you'll just never get started. Now remember, both of these tools can be used to test any website, regardless of the application's underlying framework. We've got the links here for Serenity and Canopy. As you can see, they have nothing to do with the name, but hopefully a simple Google search will get you where you need to be. You can look for Canopy UI testing and Serenity testing, and you'll immediately be found, go to the right place. And you learned that there's a site called Left-Handed Goat. So you learned something else today. So with that, we'll turn it back over to Lauren.
Great, thanks Bobby. Before we get to your questions, and we'll give everyone a moment to submit any additional questions while I just quickly let you guys know that we do have a couple of upcoming public classes that's held in our office in Fairfax, Virginia. Both are certified Scrum Master courses. One's coming up in just over a month on July 30th and 31st. And then we have another one in October, the 29th and 30th. And since you have attended today's webinar, you get 10% off the cost of the course. You would just use code webinar10 at sign up, and you will see your discount reflected. So just go to our website to sign up, or feel free to reach out to myself. My contact information will be in the follow-up email at the end of the webinar if you have any additional questions. So, okay, Bobby, let's hop to the attendee questions. First one being, what's the profile of someone who maintains these tests?
So I'll take that. There's a role that has emerged lately called you may have heard SDET, SDET, Software Development Engineer and Test. It's a little different than a QA engineer, but that's sort of a role that's sort of starting to emerge. And this is more of a combination of someone with both QA and software development skills, and they're usually embedded directly in the software development teams rather than a separate department. And they've become, these roles, SDET or SET, Software Engineer and Test, have become more popular with the increased focus on automation and shifting tests earlier in the development process.
Okay, thank you so much. The next question is, how do the tools fit into the CI pipeline?
You want me to take that?
I can talk about Canopy if you want to.
So let me tell you about the Serenity framework first, right? And so if you're developing your test cases through Serenity, like I talked about, you could integrate those tests. You could run those test cases using a build tool like Maven or Gradle, for example. You could tie your test cases to run, to a specific phase or a specific goal, in these build tools. Once you've done that, it's just a matter of configuring a build job on Jenkins or whatever CI you use. Check out the tests and then run the Maven target, right? Now, I'd mentioned this, that when you run these test cases through Maven, it spits out a report at the end of the test case execution, and it also report on the status of the test case execution, right? So if the test pass, the build job passes, and if the test fail, the build job will fail as well. And you can also publish it's an HTML report that it generates at the end of the test case execution. You could have these published to the CI server at the end of the test case execution. So yeah, it can easily be integrated into your CI/CD pipeline. It has, use these build tools, run them through these build tools, and that's how you would integrate them with CI/CD. Okay.
And on the Canopy side, there's a few ways to integrate with CI using. There's this iReporter interface that's included, and they have tools or concrete reporting examples for, say, Team City or JUnit, and then a simple HTML reporter that are offered with Canopy. Now, what that does is you would write out what you want, or you would include the Team City or JUnit or HTML reporter in your application, and then it would just be part of your CI pipeline. It would display that result. And because it's extensible, this iReporter interface, you can even write your own extensions, however you want. that's the best hook into CI. And I think there's a lot of examples if you just look at that iRecorder interface. That's it.
Great. Thank you. Next question is, why not write test cases directly using the Selenium WebDriver API?
So I could take that, and yeah, so we sort of discussed this a little bit, but you could write directly to the Selenium WebDriver API, but these tools, the Canopy and Serenity tools, are meant to provide a layer of abstraction that allows you to write high-level tests in more of a readable language and where you can use shortcuts and helper functions. Writing directly to the WebDriver provides very powerful functionality, but it can be sort of verbose and more complex than these tools. So these tools just allow it, or a little easier entry into the UI testing.
Okay, great. Our next question is, what do you mean by exploratory testing?
Do you want me to take that? Yeah. So exploratory testing, really, as the name indicates, is about exploring. And it's all about learning the behavior of the system as you go through testing, right? So when you think about testing traditionally, you would have a test plan, and you would have some test cases that list the expected outcomes, and you're really validating the system against those outcomes, right? But exploratory testing is more like black box testing. As a tester, you go beyond the test plan and ask yourself, I wonder how the system would behave if I do this, right? So you learn as you go. You explore these test cases, right? Now, you can't have a machine do that, right? I mean, a machine can only do what it is asked to do, and hence, why these tests are more manual in nature. So exploratory test essentially, is about exploring. It's about learning as you go through testing the system and just learning how it behaves. Hope that answers that question now.
Yeah, I think that was a good description.
All right, thank you guys so much. So with that, that's all the questions that we have submitted. So we will go ahead and end this webinar. Just thank you again to Bobby and Ashok, and hope everyone has a great rest of their week. And let us know if you have any additional questions or comments. Thanks, everyone.